This is going to be a tutorial on soldering fundamentals. There are a lot of good soldering tutorials online, but there are also a lot of bad soldering tutorials online, and a lot of them teach some bad habits. So what I'd like to do is do a tutorial that shows my students what I think is the proper way to do it, and also will try to conform to standards that NASA outlines in their standard soldering courses. So the basic items you're going to need are soldering iron. Ideally, you'll get one that can actually control the tip temperature, some way to clean it. These dry brass shavings are better than using the wet sponge, because the wet sponge puts a thermal shock on the tip quite a bit. Every time you touch it, it's wet, and so it cools the tip. These brass shavings are a better way to clean your iron. Need some good 60-40, meaning 40% lead solder, some soldering flux. Now there are different types. You don't want to use the type of flux that plumbers use for soldering pipe. You want some based on rosin. This is a liquid soldering flux that I like to use. It's called a no clean type. It leaves a residue, but the residue that it leaves won't attack the parts or corrode them. So I like that aspect of it. And you can just clean it off with some isopropyl alcohol. And then, you need some way to hold on to your parts, so some kind of clamping apparatus. But these are the fundamentals that you'll need. There are a lot of different soldering tips that you can choose when you're soldering. The classic soldering tip that comes with most soldering irons is just a conical tip. The conical tip is one of those tips where it's kind of good at everything, but it's not great at anything. It's nice because you can solder at any angle, but it's not great for transferring a lot of heat to a wire and so forth, because as you get close to the tip, your surface area goes down. And so what I prefer to use almost exclusively is a wedge tip. So these kind of wedge tips are really nice. This is a real nice wide one that I like to use for heavier gauge wire. You'll hear me say a lot that soldering is a heat transfer problem. And so you're trying to get as much heat from this soldering iron into the wire as quickly as possible. And these wedge tips are great for that. You can use you can get a lot of surface area. They make them much narrower too. This is a wedge tip. It's just a narrower wedge tip, so this might be good for through-hole soldering. Also good to use a wedge tip because you can get heat on the pad and also the wire at the same time. And then you'll also see some of these specialty tips like this. This is a gull wing tip, it's called. It's got a 45-degree bevel on it. These are really good for SMD or surface mount soldering, drag soldering, and the like. So that's mostly what these types of tips are used for. But you'll see me mostly using in the tutorials the wedge tip. A very important part of soldering is to make sure that your tip is clean. You see how dull this tip looks right now? Before and after, every time I solder, before I make a solder connection, you'll see me go into the brass shavings, clean that tip. You see already how shiny that looks. Put a little solder on there. Sometimes that's called tinning. Clean that tip, make sure it's nice and shiny. What that will do is allow you maximum heat transfer to the wire, because what you want to do is you want to get that heat into the wire as quick as you can to melt the solder before that heat translates through the wire or through the component into something that's not tolerant of the heat. So you want to have a real nice shiny tip every time you solder. So you'll see when you watch me solder, every time before I solder, I put a little solder on there, I clean it, put a little bit more on, and then I'm ready to solder. There are a variety of different ways that you can strip wire. This is 12 gauge AWG, American wire gauge, 12 gauge stranded wire. And I've got a couple of different wire strippers here. This is a standard one that actually has the different wire gauge numbers here, and you put the wire in there. So you put the wire in and you clamp down and you rotate the wire, clamp down again, and then you pull. Now you notice in this case with these strippers, there's some tolerance to them. Actually, it strips some of the strands off. So, and I stripped that on the 12 gauge setting. So you got to be careful with that. That's why I don't use these kind of strippers a lot anymore. I invested in better set of automatic strippers. If you're going to use one of these kind of strippers, what I do is start at a higher gauge first. So I'm gonna try to see if I can strip these at the 8 gauge setting first. And I'll clamp down and just kind of rotate the wire and then pull on it. And there you see I didn't pull off as many wires. It's not perfect. I need to pull that casing off. But that's the thing, you got to look out for these. They're just, the holes are just not always that accurate. Now, if you're a beginner, I definitely recommend something like this over trying to strip with a pair of diagonal cutters or something like this. I wouldn't use something that's not gauged unless you're very experienced, because it's very easy to cut into the wire. Now, a much better type of wire stripper you see is an automatic wire stripper like this. They have a tension setting on them. This particular set can automatically cut 34 gauge all the way to 8 gauge, so it's a really wide range. And it's got a sharp little blade on it. This here is an index that shows you how far you're going to strip the wire, and you literally just put the wire in there and it's done. And you see that it actually, I have it set for the right tension here, so you see it didn't strip off any of the strands at all. All these strands are left over from the manual one. So if you're going to do a lot of soldering, in particular critical soldering, it's nice to have a really good set of tools. My mom used to say carpenter's only as sharp as his tools. So this is about $100 stripper here. I mean, it's a big investment, but it's worth it if you're doing a lot of critical wire stripping. Let's talk about wire tinning. You'll notice that any type of soldering that we do with wires, whether it be wires to other wires or wires to breadboard, the recommendation is that the wire is always tinned first, in particular if it's stranded wire. And that just means that you put solder on it. So we're gonna tin this wire here that we just stripped, this stranded wire. So what I always do, go to the brass shavings to clean it, put some solder on this tip, go back, clean it, see how nice and shiny it is. I put a little solder on because what this will do is create a heat bridge. Helps to transfer the heat to the wire. I touch the wire, and then what I'm doing here is I want to put the solder on the wire. So what I'm doing here is that the solder I'm adding to the soldering iron is just helping transfer the heat, but I want this solder to melt on the wire. You notice there it is. Finally it got hot enough, and I put a little solder on there, and that's tinned. Then I go back, clean the tip before I put the iron away. So remember, in soldering, it's a heat transfer problem. The solder goes where the heat is, okay? You don't want to just come in here, I see this a lot, in particular through hole soldering. I'll see people put the solder on the soldering iron, and then they'll dab at the thing that they're soldering, or they'll kind of scrape a blob of solder off. That's not actually making a good solder connection. What you need to do is you're using the solder on the iron just as a heat bridge to help the heat get into the wire quickly, and then you melt the solder on the wire, and that'll give you a good connection. What we're going to talk about next is how to do wire splicing. Wire splicing is, how do I take two wires and join them together electrically? And this is where you'll see all sorts of tutorial videos online on different ways you can do this, where you just twist these wires together this way, twist them together this way. For stranded wire, people show you the mesh techniques, but none of those methods are acceptable. And the reason is because you're not just making an electrical connection, you're also trying to make a mechanical connection. Your wires are going to be subject, even when they're just installed, they're going to be subject to strain. So maybe you've wired up a wiring harness for the airplane, and now you've got to install it in the airplane. These joints are going to be subject to strain. Maybe you're wiring up a servo connector or something like that, and it's constantly being pulled on every time you plug and unplug the connector. So your wires really need to have both a mechanical linkage and also an electrical bond. So maybe if you're being chased by a dinosaur in Jurassic Park and you're trying to hotwire your Jeep together really quick and you want to just twist these together, okay. But in every other case, what you need to do is make sure your wires are spliced properly. This is a set of solid wires that I've stripped back. It takes me about an inch to do this properly. And the technique we're going to use in this case is called the Western Union method. And this is an accepted NASA method for joining solid wires. And the reason they call it Western Union method, sometimes it's called the Bell method, but it's because it's been used since back in the days of the telegraph. Excellent way to join solid wire together. And what you do is you put these two wires together, and then you just do one twist. Okay? You don't continue twisting and then call it good, because those wires will just come apart. You do one twist. And now what you do with the rest of this wire is you bend it 90 degrees and you loop it around. And you see you might even need to use a pair of needle nose or something there to make that final little twist. And you see how I've looped that around, and now I do the same thing on the other side in the opposite direction. And it gets so stiff that I can't twist it with my fingers. So I'll just finish it with the needle nose. Another name for this is a lineman splice, like electrical lineman. And there you go. And you see, not only do you have a lot of surface area in contact to give you a good electrical connection, so this would be an excellent electrical connection, the mechanical connection is almost as strong as the wire itself. And so now what we do to complete this is we solder it. And so, get it in here so you can see it better. Clean the tip. Put some on for a heat bridge. And there we go. So now we've got a good electrical and mechanical connection to this wire. And then we can put heat shrink over the top of this. So you want to make sure that the heat shrink, I'll show you heat shrink in when we do connectors, but the heat shrink should completely cover the joint and then extend, a fraction of that distance passed onto the insulation. So the heat shrink is actually holding on to the insulation of the wire. That gives you both strain relief and also electrical isolation to make sure that you can't short this joint out. So that is a lineman or Bell or Western Union splice for solid wire only. The next splice we're going to do relates to stranded wire. And this is where I see most of the unacceptable types of splice methods out there. Once again, people will tell you to do things like put them together like this and twist them, or use the Western Union type splice on this, but you can see what you're going to get is a big hairy mess. Other people talk about so-called, mesh splices where you do this kind of thing and you mesh them together, and then you kind of squeeze these together. But that's really no better because you don't have a mechanical linkage there. It's relying on the solder to hold everything together. Also, what it's doing down inside here is when you're meshing it together, no matter what, when you're squeezing this together, you're ending up with a lot of voids in there. And you want all that wire nice and neat and tightly wrapped together. It also requires, NASA requires these wires to be pre-tinned before you actually splice them together. Well, you can't pre-tin wires unless each wire is individually tinned. You can't mesh them together that way. So don't use that technique. The method that we're going to use is called the lashing technique. And I'll show you here an illustration of the lashing technique. And you can see that it's basically two pre-tinned stranded wire together, nice and neat together. They're touched together. Everything is pre-tinned, and then you lash them together with pre-tinned wire, and then you solder the whole bundle together. So here you can see I have the same sort of setup. I have pre-tinned. We tinned these already when we did the tinning example. This is 12 gauge wire, stranded wire. You see they're all tinned, so nice and solid, tight, neatly wrapped together. And then also what I have here, this is 24 gauge. I've got 24 gauge. I've also got 30 gauge that you can use, but it's bus wire. It's called, goes by a variety of different names, but basically it's just pre-tinned wire. It's not magnet wire. It doesn't have any varnish on the outside. It's just pre-tinned wire without insulation on it. But this is what we're going to use for our lashing. I'm going to use the larger gauge, the 24 gauge, in this particular example because it's easier for you to see. But you can use all the way down to 34 gauge if you want really fine wire. It's just a little harder to deal with. But I've cut off a little piece of it, and you see it looks just like solder, but this is not solder. This is that 24 gauge wire. So what I do is I put these together side by side, and I'll need something to hold on to them. So I'll just go ahead and use a pair of needle nose. So you see I've got them securely like this. And then I'll just, I put some excess on this side, and I just start wrapping. You make sure you don't overlap the wraps, and the spec calls for a minimum of 6 wraps. I like to do it a little bit more than that just to get it all the way around. Okay, and I'm done on that side, and now I can continue my wrap this way. Like I said, you're supposed to have a minimum of 6. I like to do it more just because it's stronger and I just think it looks better. And it doesn't take you but a few seconds longer to go ahead and there you go. There's the lashing. And I can cut off my excess here. And you see that not only is this electrically a lot of surface area in contact with each other, but mechanically it's a good, strong link already, and I haven't even soldered it. Now I can just come in here and hold this. The nice thing about this, everything is pre-tinned, so the solder is going to flow very well. Just add a little bit of flux. Solder iron. Get a good amount of solder on there because I need a good heat bridge. I got a lot to heat up. You'll see eventually everything will start heating up enough that the actual lash will start to melt. There it is. There you go. Now, to complete this, you're gonna have to use the shrink wrap, you see we've made a really nice, strong electrical connection. You see it's nice and smooth. There aren't any sharp edges coming off of it. Might be a little one actually right there. I didn't clip that wire close enough. But check to make sure that there's no sharp edges on it, because you don't want anything poking through the shrink wrap. But like I say, that's about as strong of an electrical splice as you can make. We're going to talk about soldering connectors now. The most common connectors that we use for electrical connections to batteries and motors and so forth are these XT60s. It's a nice connector. It's got shielded connectors on both sides. These are made by AMAS. You'll want to make sure you get the ones that are gold plated. And the terminology we use for each side of these refers to the housing. So this side is what we call the male side. This side is what we call the female side. And when you put them together, you've got a good friction fit and nice shielded electrical connection. The newer ones have actually these little caps on the end. We don't want to push them on now because they'll be on sort of semi-permanent, so I'll put those on later. But let's talk about how we solder these together. A word of warning: if you're going to be doing this to a battery, okay, so the convention is that on the battery side, something that has the positive voltage, you want to use this male end. And the reason is because you see the actual connectors inside are better shielded than they are from the female side. You see, it's easier to short these out if a wire gets in there. So usually the convention is this side goes on the voltage side. Now, if you're soldering batteries, I've seen a lot of accidents happen where people, let's say these are the battery connectors, and people will do things like cut the cables like this. Well, you're going to short those things out and they can produce hundreds of amps. You'll get a big spark and possibly even a fire. Be very careful when you're working with batteries and you're soldering these connectors on. Go one side at a time, strip only one side at a time, leave the other side covered, or cover it with some electrical tape or something like that. Make sure you're safe. But what we're going to need is the connectors. Once again, we're going to use the type that actually has the covers, but even though they have the covers, I still want to use the heat shrink, okay? Because heat shrink I use for two reasons. One is to cover the electrical connection, so each one of these wires is going to get heat shrink over the top of it and over the connector. And then I also, remember, I like the wires to actually have mechanical strain relief too. So you'll see at the end what we'll do is go ahead and over both the wires together, we'll bundle them together and heat shrink that immediately drops any force in a wire when you pull it by a factor of 2, because now both wires will take the strain instead of just one. So always be cognizant of strain relief when you're building electrical components, because you can get a lot of failures. In particular, something like a connector that you're pulling on and taking off, and sometimes people don't follow proper procedure, and instead of pulling by the housing the way you're supposed to do it, people will pull by the wires. Never pull a connector by the wires. but plan for people to do it to protect your circuit. So add some strain relief anytime you can. You generate a lot of heat when you're soldering these connectors together, and so you can actually deform the pins a little bit. So it's usually best practice whenever you're working with these is to put them together and solder them connected together like this. So that way you'll transfer some of the heat, and then also if they do get a little bit too hot and the housing starts deforming just a little bit, at least having them together will keep everything aligned. So one of the biggest challenges with these XT60s, incidentally, XT60 means they're supposed to be rated to 60 amp continuous. They can actually handle higher burst currents. But any of these kind of connectors, one of the biggest challenges is finding something to hold on to them. You don't want to use these clamps. Are kind of frustrating, to try to use alligator clamps. I've tried every type of connector clamp you could possibly find. This is one type. There are a variety of other types that you can use to hold on to these XT60s, but what I found to work the best is just a plain old clamp. This is just an Irwin quick grip clamp, and you can just put that in there, squeeze it together, and there you go. So I have found this to be the easiest and the fastest way to hold on to the XT60s. And so the first thing we need to do is tin the connections. So we'll go ahead and put a little bit of flux in those connectors. Clean the tip. And what I need to do is hold that tip in here so it heats up the connector. You want to work quickly. And I fill that cup with solder. I'm going to come around here, do it to the other side. And there we go. So usually what ends up happening if you're going to have a problem and you overheat the connector, is usually you don't have a good thermal connection between the soldering iron. It's not nice and clean and shiny. You don't have any flux in here, and what ends up happening is if you have a sort of a poor connection thermally, it takes a long time to heat up the connector. And what that does is it allows the heat to travel inside the plastic and so forth. So once again, when you're soldering, you want the heat transfer to happen between the iron and what you're trying to solder. You want that to happen as fast as possible so that the heat can't travel and damage anything. Okay, so I've done that to that side of the connector, and now I flip to the other side. You notice on this side, it's much shorter. There's actually a much shorter connector here, so it won't take as much solder. And that's it. And what you'll do is you'll cut your wires also to match the depth of the socket. So this side, you notice it had those short cups. So this is the side that, you know, I've already pre-tinned all these wires. This is a very important step. You follow the tinning instructions that I showed you before. Use flux, and then you strip the wire, use the flux, and then you tin each side. And that's going to make these connections very, very quick. So on this side, you use the shorter strip wires, and then on the other side, you'll use the longer wires. It's at this point, before you solder, you make sure that you put on your heat shrink, slide the heat shrink onto your wires independently, and then also slide on your covers. Actually, what I've found is that you should do the cover first and then the independent heat shrink. Okay. Now, I don't need to do that now because I'm only doing these short wires here, but if there's some connector at this end, or if there's a component, or if this is a speed controller, this is why you've got to slide these things on right now. I'll leave them off because we can put them on later. Okay? So we're going to connect these wires to these connectors. Now there's a standard for how you do this to XT60s. I don't know if you can see it in the video here, but this side is plus, this side is minus. The easiest way to remember this is that you see that there's a rounded side here and there's a flat side here. Round is ground. So you just say to yourself, round is ground, and that'll help you remember, okay, use the black on the round side, the ground side, okay? So we'll do that first. Round is ground. Now, the tricky part here is you need to hold on to this wire to be able to install it. Okay, and there are different ways you can do that. You could hold on to it with a pair of needle nose pliers. Just a variety of different ways to do that. What I like to use my fingers because I get better control. The problem is even if you do it quickly, it'll get too hot in your fingers. So I've found these. Basically, these things are just silicone thimbles, and that allows you to use your fingers as clamps. But you don't have to do it this way, but it does give you a good amount of control. Now, hopefully I'll be able to do this where you can see it. What I do is I get the soldering iron, I get that tip nice and shiny, make sure you get it clean. And what I need to do is, for these two to bond together, I need to heat both the cup and also the wire. I've got the black wire. This is the round side, so round is ground. Clean my iron. Make sure that tip is shiny. Get the solder heated in the cup. Get it on the wire as well, and just kind of work that wire down into the cup. Hold it in place till it's solid. Looks good, nice and shiny. Can go to the other side. Do the same thing. Clean the tip. Heat the solder in the cup. Heat the wire. push that wire down. Hold it in place till the solder flows in the wire, and release. Now sometimes you'll notice there might be, it depends on the size of wire you're using. If you're using a little bit smaller gauge wire like this, you actually might want to add a little bit more solder. So you can come in here, get everything hot again, add a little bit of solder just to fill that cup up. There we go, nice and solid. You can see what that looks like. You don't have any solder sitting on top of the wire. The solder has flowed into the strands. So you want to make sure you see. You don't want to see solder sitting on top of a wire. That'll be a cold solder joint. It won't last long. It'll be high resistance and poor mechanical bond, and it'll fail. So you want to make sure that that solder connection is nice and shiny, and you can see the strands. You can see that the solder has flowed into the strands. Now we're ready to put the heat shrink on. You can look at our connections here and see, okay, well, these wires, you see the wire, because it's relatively large gauge, the solder flows into the strands. Maybe it's bent a little bit towards the black wire. You can come here with needle nose and just gently twist the wires so that they're straight. I'm just gently doing this. I'm not putting a lot of force on it. And now you just put the heat shrink on. Okay, and then you get your heat gun. I'm using a heat gun that I use for surface mount. You can use any heat gun. This is set for about 600 degrees, 650 degrees Fahrenheit. So you see we've got a nice cover here on both of those connectors. So you don't have to worry about any kind of internal shorting or a stray wire in here jumpering across and shorting out our electrical connection. And I can put the XT60H cap on here, and sometimes you can do this by pressing it. Sometimes you need a little bit of a persuasion. You see it might not stick on one side. What I like to do is pull the connection apart, hold it on the table, and just push on the cap. You'll hear a nice click. Now you see, got a good connection. And like I said, I like to do one more thing here. I like to put one more piece of heat shrink on this. This connects both wires together mechanically. This is not for the electrical protection. This is strain relief, additional strain relief. So if anybody pulls on a wire or pulls on your connector, it helps the joints take that strain. It at least divides that force by 2 because both wires carry the load. And now that's a nice professional looking heat shrink job there. You've got both electrical isolation and you've got some mechanical strain relief. I'll do a brief discussion of through-hole soldering. Through-hole soldering is a little bit trickier than just wire soldering because you're dealing with components. For example, you've got this capacitor here. You want to make sure that you solder this to the board, but you don't want the heat to travel up the wires and damage the component. Integrated circuits and other types of components can be sensitive to heat. So the trick is to make sure that you solder the connectors to each other without damaging the component. So that's going to require quick and efficient heat transfer. So the first thing you're going to do, I'm not going to show you the whole NASA standard procedure, but basically it boils down to making sure that you clean, you flux, and then you solder. So I've got some alcohol on this Q-tip, and I'm just going to make sure that all the different connectors that I'm going to solder are all nice and clean, just in case there are any kind of oils or anything on there that might make it difficult for the solder to stick. And then I've applied some flux to this brush, and I'm just going to go ahead and flux the areas that I'm going to solder. And now I can solder. I've changed my tip temperature to 650. That's typically the temperature that I use for through-hole or SMD type soldering. So still relatively high, but not as high as I use for heavy gauge wires. Once again, you want to make sure you work quickly. I'll turn on the exhaust fan here. Same as always, you want to make sure you clean that tip. It's a little bit oxidized from sitting out. Now you see it's nice and shiny. The most important part here is making sure that your iron touches both the pad and the wire. Okay, sometimes what people will do is they'll put a little solder on and they'll just dab it. And you'll have solder stick to one side or the other, and you'll get a cold solder joint. So you want both the wire that's sticking through and the pad making contact with the iron. And so I'll go ahead and solder this part right here. You see it's much quicker than soldering wires because there's just not a whole lot of material here. Once again, touching the pad and the wire. Get in, get out quickly. I think I've got them all. Clean the iron. And now you see, it looks like we've got good, shiny, conical connections. None of them are jumpered across from each other. If you look in close, you know you've got good electrical isolation. What we want to do now is clean off some of that flux. So come back in here. Clean off the flux, As I said earlier in the video, I use the so-called no clean flux. So if you didn't clean it, at least it's not going to corrode everything, but it's still good to clean it off, make it nice and neat. Now, when you trim off the excess, you should be wearing safety glasses for this part, because these things can shoot off. And then make sure you get in the habit of anything you're going to snip off, you put, if you're right-handed, let's say, you put your left finger on top of the wire you're going to snip. So I'm going to snip this wire. So hold on to it and then snip. These things will shoot across the room on you. And there we go. And we can go back and clean this again. Go in, make an inspection under a magnifying glass or something and say, okay, did we make sure that we've got enough solder in every one of these holes? Did we end up with a jumper across any of these different holes? But those the fundamentals of through-hole soldering. Let's say you made a mistake in soldering and you want to desolder something. Your first type of tool that you should try is something called a desoldering wick, which is basically just braided copper wire. And so the solder really will want to flow into heated braided copper wire. So what you do is you just basically put that wire on the solder ball that you want to desolder, and it will just wick from the part into the copper. You see I've changed to a pencil tip now here. When I soldered this board, I was using the larger chisel solder tip, probably a little bit too large for this application. This is probably a better chisel tip for this application. But let's say I want to get the solder off of this part right here. I just go ahead and touch it to it, and you see that solder went right in there, and most of the solder is gone from the actual, I don't know how well you can see that, but you can see through the hole now. And so that's how you desolder parts, is with a solder wick. And this would work for all sorts of applications. And now almost all that solder is gone, so I could probably, I can pull that wire right out now. And then I can go ahead and move it and resolder it someplace else. Another tool that you can use, it's a little bit more fun, is a solder sucker. And here's an example of one. Basically consists of a plunger. You load it. It's got a spring inside of it, silicone tip. And what you do is you put that tip right next to the solder you want to remove. You heat the solder, you push the button, and it sucks the solder right inside. So let's see if we can remove this ball of solder right here. Desoldering is just as important as when soldering, to clean the tip, make sure it's real shiny, and get that solder hot. And you see most of that solder is gone now. It's that ball that I had there. And try it again. Sometimes you got to do it more than once to get it all out. And there you go. Yep, it didn't quite all come out. I got most of it. Actually might need to go back and finish the job with the braided copper here. Pretty much can't go wrong with this, with the solder wick. Yeah, you see that the solder is completely out of the hole now. But the solder sucker is great for removing a lot of solder all at once. The wick is a really good general use type tool. Even in surface mount technology, this solder wick is a great way to go. Once you get it hot enough, you see how the solder flows up into this away from the part. And you see now all the solder is gone from that hole. I should be able to pull that part out now. Not quite. It's really close. Need to get just a little bit more out of there. Best way to do this is not to have to do it in the first place, but everybody makes mistakes, and so you're going to need to desolder sometime. And there we go. Got that part out. Okay, so that's how we desolder. We either use the solder wick or a solder sucker. They actually make electric versions of these too. They actually have continuous vacuum. They're connected to a soldering iron. That's when you make a whole lot of mistakes continuously. Those are great. But this is all you'll need for the occasional mistake. And then as long as you don't damage the components or damage the board with too much heat, you can go right back and resolder your parts.